all human activity on this planet and beyond ultimately involves one of two things. You're either predicting the motion of objects, things over which you have no control, but you're predicting their motion, or two, objects over which you do have some control and you're controlling the motion of them by the application of force. More on that later. But this is all about motion. Okay, so right now you're seeing my laser pointer, and all of us would agree that it's not moving. Now, all of us would agree that it is moving. So what's different about this and this? Well, it has to do with this. The position of this laser pointer isn't changing over time. This one, the position of the laser pointer is changing over time. So ultimately, all that motion is change in position. So that's why we're going to say that when we are studying motion, what we're really doing is learning how to track position. And position is simply just saying where things are. So how do we say where things are in the universe? For example, we have three veggie people: garlic, Miss Potato, and Carrot Boy. How do I say where they are? There's not a good way of describing their position until suddenly we notice, oh my gosh, there's a fence in front of them, and that fence has a red balloon tied on one of the posts. And so now they can tell us where they are. Garlic says, I'm 5 fence posts to the left. Let's see, 1, 2, 3, 4, 5. I agree, Garlic. Miss Potato says, I'm 3 to the left. Let's see, 1, 2, 3. I agree. The position of Miss Potato is 3 posts to the left. And Carrot Boy, where are you, Carrot Boy? Carrot Boy says, I'm 3 posts to the right of the balloon. 1, 2, 3. That's correct. So if we have a fence post, we can use that to establish the position, to say where things are. But let's also say, oh, it turns out that the fence posts are 1 meter apart. So now instead of talking about number of fence posts from the red balloon post, we can just say, Carrot Boy can just say, I'm at a position of 3 meters, meaning 3 meters to the right of the post with the red balloon. And Miss Potato she's no longer going to need to say I'm 3 posts to the left. She can just say my position is -3 meters. Negative doesn't mean bad. It just means on the other side of the post with the red balloon, which, by the way, is at a position of 0. And Garlic is -5 meters. So now we can actually even just get rid of the fence post and just say, maybe we just have a little mark on the ground, and we can say, okay, from that mark, everything to the right is increasing positive, and everything to the left is increasing negative. And this, my friends, is essentially what we call a frame of reference. Frame of reference, assuming these guys can only go in one dimension. One dimension doesn't mean one direction, it means one dimension, meaning you can either go this way in a straight line or that way in a straight line. If you have one-dimensional motion, then all you need is one, it's kind of like a number line, but we call it a coordinate axis, where you have an origin, a 0 position, and then you have positions to the right, which are positive, and positions to the left, which are negative. We give our axes, this is a coordinate axis, we give our axes a label, and they're just like the ones you use in math class. Typically this one, horizontal, would be X, and then what is this parentheses, M? That just means that these numbers represent meters. Numbers represent meters. So you can see that basically if we want to track the position of an object, you need to make a frame of reference. A frame of reference will be a coordinate axis for each dimension of motion. In the previous case, hey, it's not letting me go back. Oh well, that's interesting. In the case of the veggie people, they could only go in one dimension, so we only needed one coordinate axis. If they could wander anywhere around on the ground but not leave the ground, that would be two-dimensional axis, so we would need to add a y-axis. And if they suddenly sprouted wings and could fly, go up, down, left, right, back and forth, then we would need to add one more axis, which is something we don't see very often, but it would be a z-axis. So that's how that works. And then you need an origin, meaning a place that you're going to call 0 position, and an appropriate scale. So for the veggies, meters might work. Remember, meters is just a little more than a yard. Feet would be fine. Kilometers, you want to, if you're going to use kilometers or miles, you're probably talking about something that can move pretty long distances, like airplanes. If you're talking about things that are very finely detailed, maybe you want to, or can't move very much, maybe millimeters or inches or some smaller scale. That's all there is to it, to a frame of reference. So to summarize, basically, to say where things are, you need a coordinate axis, which you're familiar with from math class, for each dimension of motion. One dimension or two dimension would be like here would be, you would need both a y and an x-axis. And if your thing could fly, you would need to add a third dimension, your z-axis, and that's how you would establish the position. We call that, when we're using a coordinate axis to track position, we call that a frame of reference.